Hi, welcome back. In this video, we're going to compute delta y and dy, the differential dy, for the function y equals x minus x to the third when x equals 0 and delta x equals negative 0.3. And then we'll look at what that means graphically. All right, so to get delta y, we need to look at the function f of x equals x minus x to the third. Delta y, remember, is the change in f of x from x to x plus delta x. So we're going to compute f of x plus delta x minus f of x. That's delta y. So let's plug in x equals 0, delta x equals negative 0.3. All right, so f of 0 is clearly 0, because 0 minus 0 to the third. So we're computing f of negative 0.3 minus 0. So f of negative 0.3 is negative 0.3 minus negative 0.3 to the third, using f of x. All right, so plugging those in, we get negative 0.3 plus 0.027. So I get negative 0.273 for delta y. The change in f of x, the change in y as we go from x to x plus delta x. All right, so what's dy? So remember, dy is the change in the linearization L of x. Remember, the linearization is just the tangent line at, in this case, the tangent line to the curve at x equals 0. And we call it the linearization because we might want to use it to approximate the value of the function at points near x equals 0. Use the y coordinates on the line to approximate the y coordinates on the curve. All right, so to compute dy, remember, we need to compute f prime of x and multiply it by dx. So for this function, f prime is just 1 minus 3x squared. And remember that dx is always the same as delta x. And in this case, delta x was negative 0.3. So dy evaluated at x equals 0 and dx equals negative 0.3 is 1 minus 3 times 0 squared times negative 0.3. So I just get negative 0.3 for dy. All right, so look at these two numbers. Delta y was negative 0.273 and dy was negative 0.3. And so these numbers are sort of close together. How far apart are they? So that's called the error, the distance between these two numbers. So it's always the absolute value of the difference, because the difference could be negative, and we don't care about the sign. We just want to know the distance, which is positive. So we take the absolute value. So in this case, it's negative 0.3 minus negative 0.273. And the absolute value of that number is 0.027. That's the error. That's the error we would have if we used the line to approximate values of the function near the point x equals 0. So what did we just do? So I graphed all of this in decimals. So here's the function y equals x minus x to the third. And so we were using x equals 0. Well, that means that we were using the tangent line to this graph at x equals 0. And that's just the line y equals x. Because when you compute the derivative at x equals 0, you get 1. So the slope of the tangent line is 1, and it goes through the origin. So you get y equals x. So we were interested in x equals 0 and delta x equals negative 0.3. So x plus delta x is the point where x equals negative 0.3. So I just plotted that on the x-axis. And if we look at the point on the curve that has x coordinate negative 0.3, it's right there, and then look at the point, the corresponding point on the line where it has x coordinate negative 0.3. And let's zoom in a little. So we can see there's a little bit of difference between these two y coordinates. That's the error. That's the number 0.027 that we computed, the error. Delta y is the change in y from x equals 0 to x equals negative 0.3. So it's this distance right here. That's delta y. And dy is the difference between the y coordinates when x equals 0 and the y coordinate on the line when x equals negative 0.3. So it's this distance from the x-axis all the way up to this line. That's dy. And the difference between delta y and dy is this little bit right here. That's the error. All right, I hope this helps with understanding intuitively what we mean when we talk about differentials.